In this video, I'll focus on the motion on a frictionless inclined plane. Let's say this is an inclined plane. Okay, where this is the vertical height of the inclined plane. Alright, now if you place an object on this inclined plane, the object slides downward. Why? Let's consider what happens to the object on the inclined plane. Notice that anytime you place an object on an inclined plane, the object will exert its weight vertically downwards. So this object will exert its weight vertically downwards. Now notice that anytime an object exerts its weight vertically downwards on a surface, the surface will also exert an equal but opposite force on the object, which is called the normal force. Let's say you place that same object on an horizontal surface. So if the object exerts its weight vertically downwards on the surface will exert an equal but opposite force on the object according to Newton's third law of motion. Okay, now notice that the normal force is always perpendicular to the surface and the weight is always vertically downwards. The direction of the weight is vertically downwards, while the normal force is a contact force. It occurs at the point of contact and is always perpendicular to the surface in contact. Now in this case, the normal force will be perpendicular to the surface and it will not occur vertically upwards in this direction. It will be vertical, it will be perpendicular in this manner to the surface in contact. Okay, and notice that this weight can be resolved into its horizontal component and it can be resolved into its vertical component. If we resolve into its horizontal component, then we'll have something of this nature. If we resolve into its vertical component, then we'll have something of this nature. Okay, now notice that the normal force is now equal to the vertical component of the weight. Now let's say that the inclined plane is at angle theta to the horizontal. Notice that this angle theta will be the same as the angle in this case. Now let me show you how. Now let's say this is the triangle and then we have the weights in this manner. Now since this line and this line are perpendicular, notice that it will also form they are parallel. This line and this line, they are parallel to each other. So since this forms a perpendicular line, then this will also form a perpendicular line to this horizontal surface. Now if this is 90 degrees and this has been referred to as theta, then we can say let's say this is phi, or let me use a figure. If this is 30 degrees, then this has to be 90 minus 30 degrees. This has to be 60 degrees. Okay, notice that we have that line, this is the vertical component of the angle of the weight. This is the vertical component. This is referred to as W, and then we refer to this as WY, the vertical component of the weight. Now notice that this is another perpendicular line to the surface, that is this line, the WY, which is equal to the normal force. And don't forget, the normal force is always perpendicular. Now notice that this is perpendicular and then we have said that this is W. If this is W and then we call this angle, we refer to that angle as 60 degrees, then it means that the remaining angle will be 30 degrees. Okay, so this angle is actually 30 degrees, which is the same as this angle. Okay, so if this angle is theta, then this angle will be theta. Now notice that if I resolve W, which is the weight, if I resolve it to the vertical axis, which is WY, notice that it will become W cos theta. If you don't understand how this is done, then let's bring out the triangle. The triangle is in this manner. We have angle, okay, we have angle theta here. This is the angle theta. All right, this is angle theta, and then this is wy. Okay, so this is wy. All right, and then this will be wx, which is this wx, the horizontal component of the weight, wx, and then this will be the weight. Notice that this is the angle, this is the 90 degrees angle, so this will be the hypotenuse, the longest side, okay, and then this is the opposite, which is this, and then this is the adjacent. Now we can get that using the SOHCAHTOA. In the SOHCAHTOA, the cosine of angle theta is equal to the adjacent. The adjacent in this case is wy upon the hypotenuse, which is w. That means wy is equal to w cos theta. Okay, so that's how we have this. To find wx, then we make use of the sine of SOHCAHTOA, so that the sine of the angle theta is equal to the opposite. Okay, the opposite in this case is wx upon the hypotenuse, which is w, so that wx is equal to w sine theta. So it's just about resolution of vectors. Weight is a vector quantity and is directed vertically downward. So wx is actually mg is actually w sine theta. Okay, so we'll have it as w sine theta, why this is w cos theta. This is what will happen to the object on an inclined plane, and the force that makes the object to fall downwards parallel to the surface of the inclined plane is this force, which is w sine theta. As a result, it is the component of the weight of an object that makes it fall parallel to the surface of an inclined plane. Now let's have the free body diagram of this object to show all the forces that act on the object. Okay, if this is the object, the forces that act on the object, the weights act vertically downwards. Okay, and then the component of the weight, which makes it slide downwards along the surface of the inclined plane, that's w sine theta, and then the vertical component of the weight, which is equal to w cos theta, and then the normal force, which is n. Now let's find the summation of the force. Let's see why the object slides down the inclined plane. Okay, now the summation of the forces on the y-axis. Notice that according to Newton's first law of motion, unbalanced force causes motion. So on the y-axis we have the normal force on the positive y-axis, then the component of the weight on the negative y-axis. Notice that summation Fy means vector sum of the force along the vertical axis. Now is equal to 0. Okay, is equal to 0 because the object is not moving at that point. There is no acceleration at that point. The object is not jumping up. Alright, that means the normal force is equal to w cos theta. Okay, by taking w cos theta to the other side of the equation, or by adding w cos theta to both sides. Notice that this force is balanced along the vertical axis, so there is no motion along the vertical axis. Now let's consider the horizontal axis. This is the horizontal axis. This is the horizontal axis x, and then this is the vertical axis y. Okay, all right, so on the x-axis, the only force that we have is w sine theta. Okay, so that becomes W sine theta. All right, that means the summation of the forces on the x-axis is W sine theta, and that is supposed to be equal to MA, because the object actually slides down the inclined plane. Now notice that the weight is the same thing, is equal to mass times acceleration due to gravity, so that it becomes the mass multiplied by gravity, then sine of theta, and is equal to ma. So we can divide the mass so that g sine theta is equal to the acceleration. Notice that the acceleration that makes the object force down the inclined plane, that acceleration a is equal to sine is equal to g sine theta. Now the implication is that for an object to slide down the inclined plane, it is independent of the mass of the object. The acceleration is independent of the mass of the object, as we can see in this equation. On the x-axis, there is an unbalanced force because there is a force in this direction, but there is no force in this direction. And according to Newton's first law of motion, unbalanced force causes motion. So if there is an unbalanced force in this direction, that means the net force is towards this direction, and as a result there will be an acceleration in this direction. So the object falls in this direction. So let's say you have a body on an inclined plane as shown. We can find the velocity, the final velocity of this object. Notice that anytime you place an object on an inclined plane, the initial velocity is equal to 0. You can find the final velocity of the object. Let's say that is v, where u is the initial velocity. Now to find the final velocity, recall that v is equals to u plus at. Okay, where u is the initial velocity. Since u is 0, then v is equal to at. Notice that the acceleration in this case is the acceleration with which the object slides down the inclined plane, and that is g sine theta. So the final velocity of an object on the inclined plane is g sine theta multiplied by t. Okay, in order to find the distance at which the object falls, that is how far the object falls down the inclined plane, now we can do that using the equation of motion, s equal to ut plus half at squared. Notice that u is equal to 0, so s is equal to half. A is the acceleration with which the object falls, and that is c g sine theta, then multiplied by t squared. So you can use this formula to find the distance with which the object falls. Notice that you can also use v squared equals to u squared plus 2as, where u is 0, so that v squared equals to 2as. Notice that a is equal to g sine theta, then multiplied by s, so that if you divide both sides by 2g, if you divide both sides by 2g sine of theta and then 2g sine of theta, then this will cancel out, so that s, which is the distance along the inclined plane, will be equal to v squared upon 2g sine theta. Notice that you may also want to find the vertical height at which the object falls, the vertical height of 4, where this is angle theta. To find the vertical height, since this is s, then we can, the relationship between sh and theta is that of the SOHCAHTOA. Notice that we have this as the opposite, okay, and then we have this as the hypotenuse. All right, so if this is the opposite, then we will consider this opposite, and the hypotenuse we will consider so. Then in SOHCAHTOA, that's the sine of theta is equal to opposite, which is h, upon the hypotenuse, which is s. It implies that h, which is the vertical height, is equal to s sine of theta. Okay, notice that s, okay, so you can actually use this formula to solve. But recall that S is equal to V squared upon 2G sine theta, so that H can also be given as V squared, okay, upon 2G sine of theta multiplied by sine of theta, which is this theta, which is the sine of theta. So sine of theta can cancel sine of theta, so that V squared upon 2G can be used as the formula to find the vertical height at which the object falls. Now let's consider this practice problem. An object of mass 2 kg placed on a height of 3 meters was allowed to slip down an inclined plane at an angle of 30 degrees to the vertical. What force is required to stop it from slipping down the inclined plane? So let's say this is the surface of the inclined plane, and then it is at a height of 3 meters. Okay, now it should be noted that this angle theta is the angle towards the horizontal axis. This is the horizontal axis. Okay, so this angle is towards the horizontal axis, is not towards the vertical axis. The angle given in the question is this angle. Okay, and if this angle is 30 degrees, it means that this other angle will be 60 degrees. So it implies that angle theta in this case is 60 degrees. So in order to find the force that is needed to stop this object from sliding along the inclined plane, then we need to find the force that will oppose the motion in this direction. Notice that this surface has no friction. Okay, so if the object is placed on the inclined plane, it slides downward along the inclined plane with mg sine theta, which is the component of its weight. Okay, now notice that the body will also exert its weight vertically downwards, and then we can resolve into this, which will be mg cos theta, and then there will be a normal force. The summation of the force on the y-axis, let's say that is n, that's plus n minus mg cos theta, and that's supposed to be equal to 0 because there is no acceleration on the vertical axis. It is actually supposed to be equal to ma, but because acceleration on the vertical axis is equal to 0, so it becomes 0, so that n minus mg cos theta is equal to 0, so that n is equal to mg cos theta, so it is balanced. Now let's consider the horizontal axis. The direction of that force is along this direction. Okay, is along this direction. Yeah, simply because we need a force that will stop mg sine theta. If mg sine theta acts in this direction, the force that should stop mg sine theta should be in the opposite direction. So then the implication is that the summation of the forces on the x-axis, that will be equal to, notice that summation of force on the x-axis or summation of force on the y-axis, summation of force generally it implies net force, and net force is equal to the force along the direction of motion, or force along the direction of acceleration, minus force that is opposing it. The force along the direction of motion that we desire is P. So the force that is opposing it is mg sine theta. And of course, that's supposed to be equal to ma. Okay, but because we want a situation whereby that force will bring the object to a stop, so it means that point the acceleration will be equal to 0. So if acceleration is equal to 0, then 0 multiplied by the mass becomes 0, so that P minus mg sine theta is equal to 0. As a result, P is equal to mg sine of theta. Now notice that the mass of the object is 2, and then acceleration due to gravity is a constant. Okay, we can use 10 and multiply by the sine of angle theta, where theta is 60 degrees. Okay, so Newton. If P is more than 17.32, then it will take the object upwards. because actually mg sine theta makes the object slide in this direction. If we need a force that will stop the object, then we need equal amount of force to stop this object. If this force P is more than this force, if it is more than mg sine theta, then the object will move upwards. But if this force is not up to mg sine theta, then it will not be able to stop the object. Then the object continues to move, but with less acceleration. So for the force P to stop this object, it has to be equal in magnitude but opposite in direction to mg sine theta. Now let's solve the next problem. Mr. Green slides from rest, a height 12.2 meter down a smooth inclined plane at an angle of 30 degrees to the horizontal. Calculate the distance covered after 5 seconds. Now let's say this is the surface of the incline and is at a particular height which is 12.2 meters. Okay. Alright, so this is angle 30 degrees to the horizontal. Alright, and the object moves from rest. That means the initial velocity u is equal to 0. Okay, in order to find the distance along the plane, we may use s equals to ut plus half a t squared. Okay, we have t which is 5 seconds. Okay, notice that the acceleration is independent on the mass of the object, and of course, as proven, the acceleration is g sine theta, the acceleration at which the object slides down the inclined plane. So let's say g sine theta. In this case, g is 10, and then the sine of 30 degrees, which is half, and that's supposed to be 5 meter per second. So the implication is that the s, which is the distance covered along the plane, is equal to u, which is 0, multiplied by t, which is 5, plus half, then a, which is 5, then t squared, which is 25. So that s is equal to 125 upon 2 in meters. Alright, so that's supposed to be 62.5 in meters. So the distance along that plane is this. No, we may also find the velocity along the plane, the final velocity. Notice that final velocity v um, will be equal to u plus at, given that u, the body is at rest. So the a, which is the acceleration, multiplied by 5 seconds, that's supposed to be 25 meter per second. So let's solve the next practice problem. A smooth body slides down a plane inclined at an angle of 60 degrees to the horizontal. Calculate the component of the acceleration of the body. 1. Along the inclined plane. 2. Perpendicular to the plane. B. Velocity of the body at the base of the plane after 10 seconds. And then C. The vertical height of 4. Now let's say this is the inclined plane. Okay, where the vertical height of 4, let's have that as h. Okay, now at an angle of 60 degrees, if we place an object, notice that if we place an object on an inclined plane, the weight we act downward, and of course the weight is due to the acceleration due to gravity. So I can have something of this nature, g, and then the horizontal component, that will be gx, which of course is equal to g sine theta, and of course the vertical component of the acceleration due to gravity, which is gy, and of course that is g cos theta. Okay, so the component of the acceleration of the body along the inclined plane, that's supposed to be g sine theta, and of course g in this case is given as 10, which is multiplied by sine of 60 degrees with 6. That's 8.66 meter per second squared, because this is the acceleration, the component of the acceleration along the inclined plane. Now let's find its perpendicular to the inclined plane. This is the component of the acceleration that is perpendicular to the inclined plane. It looks like this. This is the surface of the inclined plane, and then this is gy. Okay, so the gy, which is the component that is perpendicular to the inclined plane, is g cos theta, and that's supposed to be 10 then cosine of the angle, which is 60 degrees. So the cosine of 60 degrees is 1 over 2, and is multiplied by 10, that's supposed to be 5 meter per second squared. Now the b part, the velocity of the body at the base of the plane. So if the object has an initial notice that when an object slides down from an inclined plane, its initial velocity will be 0. So to find the final velocity after time of 10 seconds, okay, notice that v is equal to u plus at, where u is the initial velocity and v is the final velocity. A is the acceleration at which the object falls along the inclined plane. So notice that u is 0, and then the acceleration along the inclined plane is 8.66. So that if we multiply that by 10 seconds, which is the time, okay, that will be 86.6 meters per second. Now the c part is the vertical height of 4. To find the vertical height of 4, we derive the formula, which will be very useful in this case. H, which is equals to v squared upon 2g. All right, notice that I already derived the formula at the beginning of this video. So where v squared, v in this case is the final velocity, all right, which is given as 86.6 squared upon 2g, where g is 10. Okay, so that in meters, so that is the vertical height of 4. A block of mass 4 kg is released from rest on a frictionless inclined plane at an angle of 30 degrees with the horizontal. Find the acceleration down the plane. Oh, it's as simple as what we have been doing. So okay, so the mass is on the inclined plane, is at an angle of 30 degrees. Okay, of course the acceleration down the inclined plane, hey, as we have already proved, is equal to g sine theta. So the acceleration down the plane is just g sine theta, and that's 10 multiplied by the sine of 30 degrees, which is equal to sine of 30 degrees half, that's 5 meter per second squared.